as you get near the end of the thermochem unit, one thing you start to add on is activation energy to potential energy diagrams and catalysts. So let's take a look at this first one where we have now activation energy added in. And we know that because if it just showed enthalpy, it would be a simpler diagram. And it's still showing endothermic because your reactants are lower than the products. So here our reactants are lower than the products. So the distance between reactants and products is shown by X here. That's your delta H value. And then when it comes to activation energy, which we know this is showing, it's now adding that energy barrier that your reaction has to go over to take place. And that is your activation energy. And activation energy is always from the reactants to the top of the hill. And that's shown by Y. Now, with just knowing what this is, and then moving on to this question, it says, what would happen if you add a catalyst to the system? Catalysts have no effect on delta H. So your X value doesn't change. What it does do is lower the activation energy so that this reaction can happen faster. So this Y value should get smaller. So let's go through the options here. Saying both X and Y would decrease. Well, that's not true because X won't change. B, X would decrease. Well, that's not true because that doesn't change. C, X would remain constant. That is true. Y would decrease. That is true. The answer is C, and we can double check the last one, saying both variables would remain constant. Well, that's not true because we know Y was going to decrease. Now this next one is showing the reaction with chromium and oxygen to produce chromium 3 oxide. Now a lot of these look exactly the same, but what we want to know is which diagram correctly represents that equation. And what we're looking at, and I just took a quick little snapshot. This is from page 4 or 5 of your data booklet. And this is showing the enthalpy of formation for this reaction. What we have to remember is the units here is kilojoules per mole. So that means it's only 1 mole being formed of chromium 3 oxide. So when we're taking a look at that, right, all of these, well, you can rule this one out because it's going to be negative no matter what. But we look at the other three, what we want to look at is that balanced chemical equation. So if chromium comes together with oxygen and you get out chromium 3 oxide and you go to balance this, we would need a 3 here, which would make a 2 here, and a 4 over here. Now, when we're looking at our equation, nothing is supporting that. What we could have done and see if it would work out, because sometimes it would, is just double your delta H value so it represents 2 moles. Now, because we don't have that option for A, B, C, or D, the other way you can get around this is divide your whole reaction by 2 so that we end up representing just 1 mole. Dividing it by 2, this would become 2, and this stays as a fraction. Now we can take a look at what would represent it. So A is not true because it's not balanced correctly because it's missing those coefficients. B looks like it's going to be the answer because we have 2 chromium, 3 over 2 oxygen, and our chromium 3 oxide with the correct negative delta H and the correct shape. So B looks like the answer. C is not going to be the answer because it's swapped your reactants and your products. So now we have B for the answer and we can move on. Now, one of the last questions I included, and all of these were old diploma questions, was this numeric response. So let's take a look at knowing what is what. So the first one is saying activation energy for the uncatalyzed forward reaction. So activation energy is always from reactants to the top of the hill. So the one that shows that is number 2. So I'm going to put a 2 here. The next one, activation energy for the uncatalyzed reverse reaction. That is always going to be from the products to the top of the hill, so shown by the number 7. The enthalpy change is your distance between your reactants and your products, shown by number 9. And then the last one, activation energy for the catalyzed forward reaction. That is going to be from reactants to the top of the catalyst hill, which is showing number 1. So as always, I hope you found this helpful. If you did, please subscribe. And if there's any other video you'd like me to do for you, just leave me a comment. Thank you for watching.